Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, guys, I wanted to talk about this star in Brazil, and this is, I guess, a related installment. Um, there's this star seems to shine in the infrared spectrum. In other words, it basically has its own source of heat, and it's picked up by that. And there's a lot of celestial bodies that aren't. I mean, we basically scan the skies. NASA does with their telescopes, and they use infrared telescopes. I'll read this particular article, which is of interest in the popular science. Lucifer instrument helps astronomers see through darkness to most distant observable objects. Now, for those of you who aren't adept, look up what Lucifer is. It's just another name given to Shaitan Lanatullah, which is interesting because the Vatican happens to be a Christian faith, in case we believe them to be. I personally believe at the top they're a cult and allied with Shaitan Lanatullah. At any rate, they've named this telescope Lucifer. And why would Vatican need a telescope, right? Anyway, courtesy of Lucifer, this image depicts a stellar nursery in the Milky Way about 8,000 light years from the Earth. Such clouds are typically opaque to visible light, but infrared light can penetrate them. Okay, the Lucifer instrument helps telescopes see that light. The E and the N signify east and the north. Okay. Now, a new instrument with an evil-sounding name is helping scientists see how stars are born. Lucifer, which stands for Deep Breath, a large binocular telescope's near-infrared utility with camera and integral field unit for extra-galactic research, is a chilled instrument attached to a telescope in Arizona, and yes, it's named for the devil. Okay. Whose name itself means morning star. But it wasn't meant to invoke him, according to a spokesman for the University of Arizona, and that's the rest of the nonsense. I just wanted you to see that this telescope, just not by the Vatican, but even NASA, they use telescopes that basically scan the skies in the infrared spectrum. The infrared spectrum is something that we can't see with our naked eye because it's a heat source, so it picks up a heat source. And the star that we're seeing in Brazil at the moment, that seems to be one. The unique signature of this particular star is very different to the proton star that we're seeing as well in our skies next to the sun. This particular one, which is slightly distant from our sun, seems to be a dwarf star. And a dwarf star is like 2.5 times the size of Jupiter. Now, Jupiter is a huge planetary body. Dwarf stars are generally, on average, 2.5 times as big as Jupiter is, and so I mean it's still a substantial size, but it doesn't shine the way your regular sun does or a proton star does. A proton star actually shines much more brighter than the sun and is more condensed, more powerful. Whereas a dwarf star is the opposite. And then you've got the sun in between, which is our sun, right? So you've got this almost like a three-tier kind of situation where you've got a proton star, you've got our sun, and then you've got a dwarf star on the opposite end of the spectrum. The dwarf star doesn't really emit any sort of light, yet it's still condensed, and it's not a star to be taken lightly in terms of its influence and gravitational influence as well as magnetic influence. But I wanted to show you a little experiment of how the infrared spectrum could be visible to a camera, but not the naked eye. Now, when you look at the remote controls that you have at home, for anyone who does have a TV, you'll find that it has an LED at the front of it. This isn't me, by the way. It's someone who's done a swell job of showing an example of that. Now, you can't see the LED light up, right? This is using a phone camera, by the way. You see that little thing flashing as soon as he presses it? We'll now see what happens when he switches off the light. Now, this is an infrared LED, right? Now that's that light. There you go. That's infrared. Okay. So I mean, it's quite clear that cameras can pick up infrared, right? And this is what this particular experiment is supposed to prove. That we might not be able to see it because there's many variables, and all these planetary bodies or celestial bodies have their own signature. If it's a planetary body, it has an atmosphere and it reflects the light, so it borrows the light just like we do from our sun. If it's a star, then if it's anything like our sun or a proton star, then it emits its own light. If it's a dwarf star, then it has a heat signature where it doesn't emit the light, but it's very different from a planet. And then planets, like I said, we basically borrow light, and we have our own atmosphere, and our atmosphere absorbs that light. Then you've got moons. Moons don't have an atmosphere, hence why they just have a very, very crisp edge, and they're just they're basically circular. It's a circular rock, right? That borrows the light from the sun and reflects it back onto Earth. So I thought we'd just discuss why, I mean, like I said, these celestial bodies, they've got their own signatures and they've got certain patterns, and this is how you scientifically deduce what you're looking at in the horizon, in the sky as it's going past in its retrograde orbit. So we thought we'd cover this and try and make sense of it so that, it's we can get our heads around what we're seeing in our skies and what the cameras are picking up. And Allah subhanahu wa ta'ala knows best. Jazak Allahu khairan wa ahsanul jazaa again for your time. Assalamu alaikum wa rahmatullahi wa barakatuhu.